Right, hello everyone. We are Team 4 and we're going to present our project Splat to you, but first we're going to introduce ourselves. I am Duncan Quick and I'm a second year informatics student at UNISA.
Hello everyone, I'm Tabora Chidi. I'm currently doing my honors at WITS Computer Science. Yeah.
Hello everyone, I'm Johan Skippers, third year at UJ currently.
Hi everyone, my name is Natasha and I am doing third year in Monash University.
Cool, and then Jenna, if you want to introduce yourself.
Jenna, I'm doing second year engineering and digital arts at WITS.
Right, so the basic problem outline that we were given is that we need to design a new bursary applicant test. And that's because apparently there had been bad feedback about the robocode test. And so we were given spec to develop the test, and the test needed to be fair to all applicants, not to favor honors students over those who have come from a more disadvantaged background. Another point was that the grading needed to be automatic rather than manual, because that ate up a lot of paid work time for company employees. And the aspects to test on the test was that the test should test logical thought and attention to detail. Those were two main headings on the basic spec document. And so here we come to our solution. Splat is a puzzle game where the player must build up pseudocode blocks, and those are basically movement commands to move around the map. And the player must solve a color-based puzzle and reach the finished tile on the map. And they earn score by finishing maps. So I'm going to hand over to Natasha, and she's going to talk about our code blocks and how we implemented those.
Okay, so initially at first we didn't know what to do because we did a lot of codes, because at first we didn't know what to go with in terms of making the blocks. So at first we tried doing buttons, and then it was just messed up. And then Tabo found a way to use the Blockly library. So we're able to create the blocks. So if you want to know more about this, you can just go to the Blockly library in Google, obviously. Yeah. So you can see here we have the pseudocode. So the pseudocode is actually inside the blocks, where if you want to walk, you walk. And if you want to use a loop, for example, in the maze or in the game, you will have a part where if you want to get to a certain point, you need to walk. Or if maybe there's a junction, you can turn right or left. Yeah, so that's how it works. And then obviously I've explained the puzzle. So you can see that there are many things inside. So what makes this game a puzzle? What makes this game a puzzle is because we have certain assets. As you can see, we have the walls, the junction, and the mixes and the splats, which are the colors. And basically, when you put the blocks in the toolbox we have in the game, you'll be able to compile that to actually interact with the maze. Okay, so moving on to this, I will pass this on to Tabo.
I'll take over here. So in terms of scoring, we came across a big challenge, and the same challenge was sort of brought up when I think it was Team 3 or Team 1. Team 1 did their presentation. The point of grad students and honor students being favored over new matriculants who have maybe come from an underprivileged background. And that's an issue of experience in the field favoring them to complete solutions faster and earn more points and therefore have a higher score in the end. So the way we were thinking to go around it, after the team so graciously pointed out that our previous situation was a bunch of hot garbage, was that we removed scaling based on the difficulty. So the points per level would be linear. but the difficulty of the level presented to the player would scale based on how proficient an algorithm thinks they are. So if a player were to clear the first couple of levels really quickly using really efficient solutions, the difficulty would scale up for their test. And that would be kept track of, and their score would be made available alongside their predicted proficiency level to HR, who can then see, okay, we have an honors student who is performing at the level of a underprivileged grade 12 learner. Perhaps they're not a good candidate for the bursary. And if we have a matriculant who's performing at a second level varsity level, they're probably a good candidate for the bursary. So now we can move on to demoing. Oh dear. On this laptop, we don't have the tutorial slide, so I'm just going to grab my laptop and share that on Zoom, and hopefully we can get that up there so people can see. Okay. Right, so we'll skip the tutorial slide and go to the demo.
So this is the easiest level. This was originally our testing level. We had an easy level, but that's now the medium level. So I'm just going to quickly show how you interact with the game. So the first thing you would need to do is, this mics. Okay. First thing you need to do is drag a start block, which is always the starting point of any code. Let's try solving this maze first by just adding a walk statement. Let's see what that does. Okay, so you walked one tile, you did not reach the end. Okay, so you need to get to this ending tile here, the flag. So let's try a loop. Let's say you loop until you've reached the end and you walk. Let's try that. Start. Okay, now you're stuck in front of the flag, but you're blue and the flag is purple. So you're stuck in an infinite loop because this code cannot complete. Let's try something else. Okay, so now the player is going to walk from here to this red splat and then turn around. That's the turnaround command. Let's try that. Let's see what that does. Okay, so now you have created the purple color by first walking over the blue splat, then over the mixer, and then to the red, and then again over the mixer to create purple over here. Then you just need to turn around again and reach the end flag. Yes, this is the easiest. Fine. Okay, like that. And you turn purple, and you've reached the goal. This is the easy level. Every level has a preview solution, so you can see what the intended solution looks like this. And then Zobel will show the other levels.
Okay, this medium level was supposed to be the easy level, but it was too difficult. So I'll just preview, and while it moves, I'll explain what's going on. So it can detect the junction, and when it gets to this, it turns red. This is a gate, so it has to be red to go through the gate, and it's going to turn blue so it can go through that blue gate as well. Now it's yellow, and it needs to go through the yellow gate and junction. And then obviously it needs to be yellow to actually finish off, and it's done. And then this is the hard level. So the mechanics are similar as well, except that we've added the banks. Yeah, the banks. We've added the banks, which you deposit the color that you currently are to a specific index that you supply. Then you see now we've mixed. Oh, sorry, that's the mixer. Now we've mixed purple because we used red and blue to go through this purple gate. And then this is the bank where I take yellow and deposit the yellow here so that it could be used later on. Go through the purple gate and then you're done. And then this is the most difficult one, Dark Souls.
Right, so the preview was put here mainly for the demo to demo the solution because it would take a very long time to build the solution. No, because part of the test, and these levels are quite difficult. Part of the test is testing your problem solving and cause and effect thinking. And solving the actual puzzle in terms of figuring out what to do is also part of that. So this is the Dark Souls level. If you want the true Dark Souls experience, don't use more than 31 walk commands to solve this. That's how many we were able to solve the puzzle with. So give it a shot if you'd like. Basically, this level incorporates every single tile that we have in the game. There's the bank that the player just deposited the red at the mixer with and now has mixed purple together. And the player's now deposited blue by that yellow mixer and needs to go collect the yellow on the yellow mixer so that they can make orange to eventually finish the puzzle. The banks work using a deposit function that the player can call as a code block, and they pass an index of the bank to the function. The index is visible on the map so that the player knows where they are depositing to. And that's how we implemented function calls. The way the scoring would work is that it would favor using loops and conditions over spamming commands, because it would put you at a higher predicted proficiency level if you were to use less commands. And our command structure works in such a way that the size of array, which would detect the number of commands used, would count a loop as a single command. And so the level's just about to finish. The player needs to collect the green, place the green by the finish at index 3 by going to the bank and calling the deposit function. And then the player can grab the purple splat next to the bank and go to the finish.
Oh, there's one thing we forgot to show you guys. So if you scroll up, really, I want to move this thing. How do you move it? Okay, so this is the only level that has the timer because we want to see if you can really solve this problem. So to all of you who are gonna try this, like a future Bursars, somewhere, if they can see me somewhere, you'll really need to really be good for this level. Yeah, thanks.
Right. We do have a slide for future developments that Jenna's going to bring forward to us of features that we would still need to implement.
Okay, so for further development, we'd like to implement the metric collection so that when people start doing the test, the game can collect information about the person, find out what level they are, and then the game will scale the difficulty according to that. And yeah, that would be the difficulty scaling based on the metrics that were collected. A level editor so that the HR, BBD, and the people that are going through the Bursars can edit the levels so they can test what they want to. Conversion from the JS command objects to code blocks on the web page is basically just converting the previews that you hard coded and putting them into the code block so that you can see what the correct solution would look like in the actual code blocks. Making better interfaces using something like Bootstrap instead of using a lot of CSS. Optimizing the rendering so that the pages render more nicely. And as they do now, they're a little laggy. Implementing storage and access to scores on a server maybe, and then also obviously making a function block to be able to test functions for the verses.